Alright, guys, let's talk about some extra proof examples. So we are going to choose the best option that fills in the blank in the following proof. We are trying to prove that quadrilateral INOL is congruent to quadrilateral KMOJ. Oops, sorry, we're not trying to prove that. That's our given. Silly, Mr. Judd. All right. We're trying to prove that these triangles are congruent. Now, what's great about this is we already know that a bunch of stuff is congruent. Because remember, if we know that quadrilateral INOL is congruent to quadrilateral KMOJ, that means that we know that, like, say, hey, angle I and angle K, those are the first things there. So I know that those guys are congruent. I don't know if I'm going to use that in my proof, but I know it. I know a bunch of other stuff too, like, say, I know that OL and OJ are congruent. Don't know if I'm going to use that either, but hey, I know it. Let's actually look at what we're going to use. If I'm looking over here, first we just give the given. Oh, and hey, we do actually end up using OJ and JL right here. We say those guys are congruent, but then we decide to say, let's go ahead and mark that, JO and OJ. I can't even read those. Okay, so this one here, J to O, right here, and O to J, and L to O. All right, cool. And then NO and MO, those are congruent as well. Let's go and mark those in green. NO and MO. Cool, those are congruent. Hey, we got congruent sides. And then we go off and we say, hey, JON, where's JON? JON's right here. And we say, hey, that is congruent to LOM. Hopefully you're noticing here that we have two lines crossing, this line right here and this line right here, which means we have vertical angles. Oh, hey, vertical angles is an answer choice, and that's the correct answer choice. And then once we know that we have the angle in between two sides, that's giving us the side angle sides. The angle is in between the two sides. Let's go ahead and solve this guy. Let the triangle KIJ be isosceles. Ooh, we're going to probably use that. Remember, isosceles means you have at least two congruent sides. And with KI and IJ being congruent. Oh, so we have those two congruent sides. If segment IL bisects both the angle KIJ and the side KJ, okay. So we got that bisector bisecting two things, this side, which means it's split in half into two equal pieces, and this angle means these two angles are congruent. We got some information there. That's nice. So we copied down our givens. We go ahead and label our picture. Now we know that KL and JL, these two I marked with the double tick marks, those are congruent by the definition of a bisector. And then we need to prove something else congruent by the reflexive property. Now, reflexive property means something is equal to itself. Well, what's the only thing the triangles share? The things the triangles share are I and L. So I'll go ahead and mark that. Sweet. That's IL is congruent to IL. Now, once we have all three sides marked congruent, we know by side, side, side postulate that the triangles are congruent. All right, let's look at this guy. We're going to prove that the triangle UVW and UXW are congruent if UW bisects the angle VWX. Okay, VWX is right here. So I know those two angles are congruent if the angle is bisected. And then I know that VW and WX are congruent. Okay, cool. So that's this guy and this guy. Then we need to say, hey, UW is congruent to UW. Of course, that's the no-dub principle or the reflexive property. Hey, we got a side, an angle, and a side. Well, that means our triangles are congruent. Now, you'll notice we need to make our congruent statement, which is actually already made for us. So let's just go ahead and copy that down. We already have the UXW part right here. So all we need is the first part, UVW. There's our answer. All right, let's talk through this guy. Prove that VCA and ABV are congruent by choosing the option that best completes the proof. Now, we are given that AB is congruent to CV. So AB is right here, CV is right here. Okay, those guys are congruent. We are given that AC is parallel to BV. Okay, interesting. Let's see what we do. Okay, so first we write down our givens, that's fine. Yeah, we got that. All right, and then we're trying to prove that CAV and BVA are congruent by alternate interior angles. All right, let's go ahead and look at what that looks like. All right, so we know that CAV, that's this guy, is congruent to BVA, that's this guy. And hopefully you're noticing those parallel lines in that transversal. That's what's giving us the option to say those are alternate interior angles. Okay, and then what else do we get to know? We are told that VAB is congruent to AVC by alternate interior angles, which would mean that these would need to be parallel, but I have them marked congruent. And then I'm looking at this and I notice something. I should not have marked them congruent. We don't know that. Both of these say parallel. So I should have marked this with a double parallel arrow. Those are both parallel. We don't know whether or not they're congruent. That's on me. I'm sorry. Okay, so we used our parallel lines to mark things congruent, mark angles congruent, because that's what parallel lines are good for. And then we say AV is equal to AV by the reflexive property. There, that's when we get a segment equal to each other, equal to another. The segment that is itself shared between the two triangles. And so then we get to say, hey, because we have an angle, a side, and an angle, and the side is in between the angles, our angles are congruent. Now that we know that the triangles are congruent, we can actually do our last step, which is to prove VAC congruent to ABV. Let's see, VAC is right here, and ABV is right here. Now, those are corresponding parts, so we can use the corresponding parts of congruent triangles are congruent, which is what we've written right here, just using CPCTC. So now we can say angle VCA is congruent to angle ABV by that corresponding parts of congruent triangles are congruent. And which answer choice is that VAC and ABV. So that's all right, cool. And that is our video on proving triangles congruent, extra examples.